morning, students. This is Dr.GVR Seshagiri Rao, Associate Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So, in this session, I want to discuss about design procedure of knuckle joint. So, already in previous sessions, we have discussed about quarter joint design procedure. So, same as here also, in quarter joint, knuckle joint, you have to apply the procedure. So, knuckle joint is used to join two rods with the help of a knuckle pin. So, as shown in figure, the assembly is given. So, here two or more rods subjected to tensile or compressive forces, so are fastened together. So, their axes are not in alignment but meet in a point. So, the applications are elevator chains and valve rods, etc. So, whereas in the quarter joint, you can join only axial rods, but in this you can join their axes are not in same plane or not in alignments. See, in this slide shown the assembly of a knuckle joint. Mainly it consists of two rods. One is high end and another one is fork. This one is called as a fork and this one is high rod and knuckle pin. So these are the main components of knuckle joint. See, in this slide shown the knuckle pin and a fork end and collar, taper pin and a eye end. So the eye end is inserted in this fork end and then with the help of knuckle pin it will be assembled. For this design calculations, consider the knuckle joint. Let P is equal to tensile load or acting on the rod. So it is subjected to tensile load. D is the diameter of the rod and D1 is the diameter of the pin. So let's take D2 is outer diameter of the pin high and T is the thickness of a single eye. So T1 is a fork thickness. Let tau and sigma c the permeable stresses for the joint material in tension and shear and crushing. It depends upon the material. These dimensions are very important while designing a knuckle joint. For this purpose, first we will consider the rod in tension failure. So when a rod is subjected to, the eye rod is subjected to tensile load. So find the diameter of the rod. See here that P is the tensile load and D is the diameter. The rod cross section is always circular one. So for this, the area of rod, pi by 4 into d square. So calculate the stress, how much stress induced when it is subjected to tension. So that is sigma T is equal to P by into 5 by 4 d square. So by using this equation, you may calculate D. So diameter of the rod. Similarly, the second one, failure of knuckle pin under shear. So area of failure and stress induced to calculate. So area of this failure 2 multiply with pi by 4 into d square. So here occur double shear. So that's why I need to multiply 2 into area. So the knuckle pin diameter you may calculate by using shear stress equation. P by 2 into 5 by 4 into d square. So calculate D1. Next, third step is failure of double eye under tension. double I rod. So the area of failure d2 minus d1 multiplied with t1. So two sides the failure occurred. So 2 multiplied with d2 minus d1 into t1. So stress induced sigma t is load upon area. Substitute in this equation. You may calculate T1. Next, fourth one is the failure of double I under shear. So when it is subjected to shear load, the area of failure you may calculate by using this empirical relation. A is equal to 4 into T2 minus D1 by 2 multiplied with T1. Similarly, A is equal to 2 into D2 minus D1 to T1. So finally, calculate the stress induced. So shear stress is equal to load upon area. Next point step is failure of double I under crushing. Area of failure in crushing when it is subjected to crushing load. So calculate area T2 into T1. The stress is load upon area 2 into T2 to T1. So you may calculate here T1 under crushing. Sixth one is failure of single I under tension. Area of failure is D2 minus D1 into T, as shown in figure, and stress induced load upon area. Seventh one, failure of single I under shear. The area of failure you may calculate by using this empirical relation, and similarly the stress also calculate. So you may calculate T. Next, eighth step is failure of single I under crushing. Which area under the crushing? So calculate the area D1 into T. So finally calculates crushing stress load upon area D1 into T. You may calculate here D1. So this is the procedure of a knuckle joint. Now same procedure apply for this problem. Here given design a knuckle joint to transmit 150 kilonewtons. The design stresses may be taken as 75 megapascal in tension and 60 megapascal in shear and 150 megapascal in compression. Shear stress, compressive stress and tensile stress values are given. So and transmit 150 kilonewtons the load, the tensile load P also given 150 kilonewtons. So you have to design a knuckle joint to transmit this much of load. So procedure already we have discussed. As for our procedure, you can solve this problem. So apply those empirical relations and calculate all required dimensions of a knuckle joint. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.